similar triangles have areas of 76 square centimeters and 931 square centimeters. Determine the ratio of their perimeters. So we're kind of working backwards from what we had done in lesson 87. So let's just start out with, I guess I'll just call this the small, and this one is going to be the large, right? So we're going to have those two ratios. I'll put the 76 in the numerator, the 931 in the denominator, since that's obviously where they belong. So now what we need to do is write the ratios of their perimeters. So these were squared values, right? So how can we get back to just the ratio of the perimeters, which is like a non-squared value? Okay, so let's take the square root of this. Take the square root of this and the square root of this and write it as a ratio. Now, the problem is those both look really, really ugly, okay? So here's what I did when I solved this. I said, well, I have no idea what these are. Let me just plug these both into my calculator. Well, when I plugged it into my calculator, I got approximately 0.286 and some change. I forget what else was at the end there. But I thought, ratios, we don't usually write ratios as decimals, what to do? So on my little cheap $10 calculator, I just changed this decimal and I tried to change it into a fraction. Wouldn't you know, it came out to a nice fraction. It didn't give me an error message. So that tells me that this could actually be simplified another way, and I think it has something to do with the square root of 19. The square root of 19 goes into both of these, and so then you would be able to cancel the square root of 19 on the bottom and on the top. But truthfully, if you have this answer, I will accept it because it technically does represent the approximate ratio, or actually, yeah, this would be an approximate ratio. But try it. Try in your calculator once you leave all of this value in your calculator and see if you can't get it to change to a fraction for you, and it'll be nice and straightforward, okay?